Everyone, do you remember yesterday from the chart which kinds of energies we said we're going to cover in grade 11? We only said we're going to cover 3 kinds of energy. Which one? Kinetic. What was the second one? Gravitational. They usually are covered together. And then the last one on its own is what? Thermal energy, or another known by what? By heat. Okay? So, kinetic energy. What was the definition of kinetic energy from the chart? It was the shortest definition. Energy due to what? Motion. All an object needs to have kinetic energy is to be in what? Does it matter if it's speeding up, slowing down, or cruise control? Nope. Just has to be in motion. Kind of like what? FK with kinetic friction. The object just has to be in motion. What kind of motion? Who cares? The faster it is, the more what? The more kinetic energy. Why? Because if you hit something with what? With a lot of speed, that means you're imparting a lot of what? You're transferring a lot of kinetic energy to it. Perfect. Okay. So the definition of kinetic energy is the energy due to motion. Okay. What was the symbol for all energy? Any energy is symbolized by what? Small or capital? Capital E. And is it a scalar or a vector? All energies are scalars because it's just an amount of what? It's the amount of work capacity it could do. However, now we need what? We need subscripts. Any guess? It is EK. Uppercase K, lowercase k, doesn't matter. Just EK. All right? So EK is the what? Is the symbol for kinetic energy. Okay? Oops, my bad. EK. All right? Now, how do you calculate the energy, the kinetic energy contained in an object in what? In an object in motion. This is one of the most important equations in all of physics, both classical and even advanced physics as well. Okay? The equation is, everyone, this. The kinetic energy of an object only depends on two things. It depends only on its what? On its mass, how heavy it is, and also its what? Its speed. It does not depend on what? On anything else. It does not depend on, well, you could argue, does it depend on its acceleration? I mean, in a way, I guess, because speed itself depends on what? Speed itself depends on acceleration, because speed, basically, if you accelerate, that means your final speed is going to be high. If you decelerate, that means your final speed is going to be lower. But in general, at any moment of an object's motion, how much kinetic energy it could transfer to something when it hits it is only dependent on how much mass it has and how fast it's going. That's it. Okay? Now, what is the equation? The equation is super important because it has what? It has a power of what? A power of 2, just on top of what? Just on top of speed. Very important. Now, whenever they come up with any equation in physics or chemistry or geology or science or whatever, what do they have to check first? They have to check the what? They have to check the units. Now, what are we still covering at the end of the day? Energy. What are all energies measured in? What's the unit of measuring both work and energy? Joules. So the first thing we have to check is what is, does this weird equation boil down to a joule? I don't know. Let's see. First of all, is this a variable or just a number? Doesn't. Do numbers have units? No, they don't. It's just a number. Numbers are basically just what? Scalar values. So this has no units. Think of it as like a cosine or a sine or a tan or whatever. M is what? Mass. What's the unit for mass? Kilogram. Okay, so there's no unit for half, but there's a unit for the kilograms. Okay. Next. Oh, yeah, there we go. Okay. Speed, but it has to be what? Okay, so that means what? Meters per second. Remember, everything has to be standard from now on. Meters per second with a power of what? Okay, I guess I can simply, you know what, distribute the 2 on top of the m and also on top of the s. So I get kilogram times m squared over s squared. Now I get to what? I get to play with this by splitting it up. So I'm going to choose to what? To split. How many m's do I have? I have m times m. So I'm going to choose to split 1m and make it with the what? Make it with the kilogram and take 1m and keep it by itself. So I'm going to get kilogram m over s squared, which is this guy, times what? Times a single what? Again, what do you measure using kilogram? What do you measure using meters per second squared? No, meters per second squared. What's mass times acceleration? MA. What's MA? F net, which is what? It's a force. And how? What's the unit of force? Nice. All of this guy in bracket is just a what? Is just a Newton. Yes. And this guy is just an M. What do I have here? Newtons times? No, 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 no. Newtons times units. Newtons times. Newtons times. Yep, it is a joule indeed. Oh, again, does this have a unit? No, it doesn't. Those are unitless things. Cosines, sines, tans. How many people have heard of secant, cosecant, and cotangent? Yeah, they're just fancy ways of saying what sine, cosine, and tan, but just flip. Not inverse. I wouldn't call them inverse. Everyone, yes. So I wouldn't call them inverse because inverse means what? An inverse function. I would call them flips, or what do you call it when you flip something in math? Starts with R. Reciprocal. By the way, they're never called what? Inverses. What's the inverse of sine? Sine inverse. What's the inverse of cosine? Cosine inverse. Inverse of tan. But what's the reciprocal of sine? Cosecant. Do you see the difference? Never say inverse. You can say reverse, you can say flip, or you can say what? What's the official word? Reciprocal. But do not say inverse. Okay? So that's it. Is this a joule now? Everyone, is this a joule? Yes. Why? Because this used to be a force, and this used to be a meter, and force times distance is newtons times meters, which boils down to be a joule. So is this equation legit? Unit-wise, it sure is. Okay, this equation is super, super, super important. Even actually in what? In sorry. So let's check the units. Yes. Okay. All right, everyone. Let's play with that is a joule. Yes. Okay. Everyone, go ahead and copy that down. So, or do you have it? Yes. Okay. So everyone, I want to show you something. Let's actually investigate just like a quick experiment. So suppose we have an object. Doesn't matter what the object is. Big object, small object, I don't care. I care about how many things only? How many? Two things, mass and speed. So we are going to say that suppose we have an object with a mass of 2 kilograms and a speed of 3 meters per second. And the reason I chose those numbers is because I did not want my final answer to be like a decimal or a fraction. I just want it to be a clean whole number. And yes, and if I chose 2 and 3, it plays out nicely that half mv squared is half times 2 times 3 squared is a perfect what? How many? What does that mean, everyone? If you have an object with a mass of how much? Mass of how much? Let's say this is like a heavy cup or a heavy mug, 2 kilograms, and it's going at what speed? And it hits something. The maximum amount of energy it could push it with is how much? 9 joules. Okay. All right. Okay. Now, everyone, pencils down. Question for you. What was the equation again for EK? Half m. Okay. Let's investigate something. Let's investigate the effect of changing mass versus the effect of changing what? The effect. Again, how many factors do we have in this equation? 2. We only have it dependent on mass and so let's what? Let's have, does anyone know what's a controlled experiment? What's the meaning of a control experiment? What does that mean? You keep everything the same, but you only change how many things? 1. By the way, is it wise if you do an experiment and you change 2 things at once? Why not? Because then if you see a change in the final outcome, you don't know how much of that change is due to what? Each variable. So you fix how many things? Everything except 1. You change only 1 thing at a time. Single variable change. Okay. So one time I'm going to change what? While keeping what? Speed fixed. And one time I'm going to change what? Speed while keeping. Okay. So let's actually what? Again, pencils down. I think it's already almost filled for you, but let's actually what? Understand what's going on. Okay. So EK original is 9 joules. Okay. All right. How does this work? I don't know. Let's calculate the what? Let's calculate the new amounts. Now, what did I only change here? Mass. What was the old mass? 2 kilograms. What's the mass now? So what's the new calculation? Half times 4 times, well, what's the speed still? 3 squared. So what's half times 4 times 3 squared? Half times 4 is 2. 3 squared is 9. 2 times 9 is 18. So that means what? If you have a mass that is 4 kilograms, still moving at the same what? Still moving at the same speed. When it hits something now, how much energy is it going to give it? How much energy is it going to give it now? 18 joules. Okay. Let's do what to the mass now? Let's what? What does triple mean? You take the original number and you multiply it by 3. So the old mass was what? 2. What's 2 times 3? 6. So the new mass is 6. Half times 6 times 3 squared. What's the new energy? 27 joules. Quadruple. What does quadruple mean? Multiply by 4. So my old mass is 2. 2 times 4 is 8. So it's half times 8 times. I know it's easy. Like you're probably saying, why are you doing this? We understand what's going on. Hold on. 36. Are we good so far? Okay. So apparently, if I double the mass, can someone relate this number to this number? How big is 18 compared to 9? No, don't tell me 9 more. I don't want you to do it as a subtraction. Give it as a ratio. What's 18 compared to 9? It's what? What's 27? So what do you conclude? Whatever you do to the mass is going to be the same thing that you end up doing to the what? To the kinetic energy contained in the what? In the object, okay? So we understand. Do we agree with this table? Okay. Now I'm going to do what? Everyone, eyes on me. I'm going to do what? I'm going to reverse now. Instead of changing mass and keeping speed the same, I'm going to do what? Keep mass the same and change speed. Okay? Whoa. Are those the same final outcomes or much more? Okay. What was your old speed? What was your old speed? 3. What's double of 3? But now it has to, by the way, now what's the mass? The mass is kept at what? The old 2. So now it's half times 2 times 6 squared. Okay? So now what? If I double my speed, I get how many joules? If I triple my speed, I get how many joules? Quadruple. Okay, now let's compare these numbers to this one. Everyone, what's 36 divided by 9? 4. What's 81 divided by 9? 9. What's 144 divided by 9? No, 16. What does this tell you? Which one affects the EK more? Changing the mass or changing the speed? Can you guess why mathematically? Look at the equation. The speed is getting what? What does that mean? This equation, the original equation, EK equals half mv squared. By the way, what's the power on top of V? What's the power on top of M? No, M. So the equation is EK. Hold on. Some people said 0. What's the power on top of V? 2. We don't disagree with that. It's there. What's the top of power of M? Why is it not 0? Because remember, anything to 0, everyone, is what? If this was M to the 0, you would have nothing here, right? And EK would only depend on what? Which is weird. That doesn't make sense, right? Are you telling me if you're hit by an electron or a truck moving at the same speed, you feel the exact same push? No. So what has to be a factor? Mass. So the mass is here. But what's the rule? If a variable appears by itself, what's the power on top of it? 1. That's why we never mention it. Interesting. Everyone, what do you call this equation? This is the equation of a what? Oh, hold on. You jumped way too far. You're anticipating always like a high thing. What? This is what? Our friend, the equation of a what? Of a straight line. Why is this a line? Because what's the power here? There we go. So what do you say about this equation? Is this equation quadratic in mass or linear in mass? No, in mass. In mass. How does it depend on mass? Quadratically or linearly? How does it depend on speed, though? Do you see the difference now? So what does that mean? Where do you get more profit? If you change mass or if you change speed? Apparently, if you change speed. Now, here's my question to you. What's this number? What does double mean? What does triple mean? What does quadruple mean? So that means what? However you change the mass, you end up exactly the same way changing the what? How do you get from double to 4? You square it. How do you get from 3 to 9? How do you get from quadruple to 16? That's why without even what looking at the number, when you said, is it 12? I said, no, it's what? 16. What does that mean? However you change the what? Let's go velocity, all right? But however you change the what? The speed, how do you end up changing your EK? Same effect or square the effect? Square the effect. So what do we conclude? A 70-kilogram athlete is running what? In the what? Okay, what numbers do I have? Do I have the mass of the athlete? Do I have the speed of the athlete? Do I have the distance he or she ran? EK equals half 70, 12 squared. Well, let's bed mass. So half times 70 is 35. And 12 squared is what? 144. How much is that? Sorry. How much? 5,040, I think. 5,040 in what unit? Sorry, 40. In what? In joules, in legit joules. Yes, we do. What's the sig fix situation? I've got 3 here, but I've only got what? 2 here. So this would be what? If I cut it at 2, it would be 5,000, right? Like 5,000 joules, right? Problem with 5,000 joules according to our rules is that it's only how many sig figs now? Crap. How am I going to make this a 2 sig fig? I have to use what notation? Scientific notation. So I write it as what? 5.0 times 10 to the 3 joules. Now it's legit what? 2 sig fig. Again, I usually try to deviate as much as I can from giving you answers that could end up having you or imposing on you that you have to do the scientific notation. But if it happens, you know now how to deal with it. Okay? All right? Okay. Next one, experiment. A dynamics card has a kinetic energy. So do we already know the EK? Yes, we do. So that means, is this going to be a forward or a backward problem? Okay. They could ask us for one of two things. They could ask us for how heavy or how fast. Which one are they asking for? They're already giving you what? Speed. So that means they're asking how heavy is the car. Okay. Start the same way. EK equals half mv squared. Okay, everyone. Can we plug in numbers now? Can we? You know what? I want to give you a taste of what? Symbolic manipulation. Imagine if I asked you to not plug in numbers now. Imagine if I asked you, play with the symbols first. Solve for the mass here. What would you do first? What's the most annoying feature of the right side? Is it the square or the fraction? It's the fraction. Second, multiply both sides by 2. So you multiply this guy by 2, and you multiply this guy by 2. So 2ek will end up being just what? mv squared. Now, am I solving for the speed or the mass? Which means both sides now have to be divided out by what? By the v squared. Yes. So that means what? Mass equals double the ek divided by v squared. Great. And then we just plug in the numbers now. 2.42 divided by how much? 5 squared. That will be 8.4 divided by 25. That is times 4 times 4, 3, 3, 6. Am I correct? No. Am I correct number-wise? Yes, it is. By the way, does that need to be square root or anything, or are we good? We're good. By the way, what's the unit right now? Is this grams or kilograms? If you start with standard, you should completely guarantee that you already going to end up with standard. So kilojoules, so I mean kilograms. However, what's my sig fig situation? 2 and 2. So that has to be cut here. Obviously, they chose, oh, yeah, good. How many grams is that, by the way? How do you go from kilos to grams, to single grams? You times it by 1 kilo. Kilo is 1,000. That's about 340 grams of mass. Done. Okay. Make sense? That's it. That's all you need to know about EK on its own. Okay, everyone, what's the next subtopic? Instead of kinetic energy, gravitational energy. Can someone remind me from the chart yesterday, what is gravitational energy? It's the energy due to what? Elevation above the what? Above the surface of any planet, technically. Okay, everyone, what do you think the symbol is? Come on, guys. What do you think the symbol is? Why small g and not capital G? No, I am not saying you're wrong. I always say this question. Why is it small and not big, or bigger not small? How many people say it's E capital G? Capital G. How many people say it's E small g? All right. Who said E capital G? You did? Give us a reason. Why are you going with capital G? I'm sorry, say again? Interesting. So no, that's amazing. Because I'm using the word what? Gravitational. You're like gravitational, not gravity. So capital G. Okay, I totally get that. However, my question to you is, do you think dropping this down does depend if I am very close to the planet or very far? If I drop this from Mount Everest, would it go down as accelerated as if I drop it here? Which one would it, where would it have more acceleration? Here or on top of Mount Everest? No, where would it have more? Where would it be closer to the center of the Earth? Here or Mount Everest? Down here. So what does that mean? Does the proximity, closeness to Earth's surface matter? What does that mean? Should that be more dependent on capital G or small g now? You got it. See, you picked G, capital G, because of the word what? Gravitational. The word gravitational here is nothing more than a title, has nothing to do with actual what? Gravitational force. It just means what? It is due to the elevation above the surface of a what? Of a planet, which means what? The closer you are, the more it matters. Done. So what's the symbol? E small g. All right, ladies and gentlemen, here's the equation. Mass times the gravity of the planet times what? H. Let's play with the units. What's the unit for mass? What's the unit for just the g? Just the g. No, not the value. The unit. It's acceleration. So it's what? Meters per second squared. Is this the same thing that we had when we analyzed the EK units? Same exact thing. We also built what? Newtons times what? Which is what? The unit for work. Which is what? What's the unit for work and energy? You got it. Ta-da. It doesn't matter how, everyone, it doesn't matter how accomplished a physicist or a scientist or an engineer is. Once they discover a new equation or formula, the first thing they do is check out the unit. Question for you. What if someone proposed, nah, this is wrong. Okay, what do you want? The G should be squared. Would this ever end up being a joule? No way. Because then you'll have a G squared. That's what you're claiming. So that means what? This will be what? This will be squared. And this will be to the power of what? Yeah, good luck compressing that to a what? To a single joule. You have got to check the validity of the meaning of the equation. That's what units tell you. By the way, you could say, hold on, what about the factor of a half? You see what I mean? Like you might say, why does this one not have a half? It's a question that we will actually somewhat answer in grade 12. Just know that the equation is 100% legit because it is actually what they use to what? To build pretty much everything. Okay. So how many people understand? How many people understand this joke? Do you remember yesterday what we said about the word potential? When I said, what does it mean when I say Ali has so much potential? He showed when you have potential. Have you shown it yet or no? Okay. Now, if you have the potential, it's still where stored. Because when you're standing on top of a building, what do you have? You have what? You have you have elevation, which means what do you have stored in you? Gravitational. Do you see what I mean? I do not use the word potential because I always assume it's in what? All of them except kinetic. If you are moving, you're using your what? You're using your energy potential. That's why. Okay? Why do you think I chose a mass of 5 and an elevation of 3? Because if I choose a lot of other numbers, this decimal is gonna survive. I don't want the decimal to survive. So I chose 3 and 5. Okay. Question to you, everyone. What was the equation again? EG equals what times what times what? Come on. MGH. Okay, everyone. MGH. Say it again. MGH. What's the power on top of the M? What's the top? What's the power on top of the M? What's the top? What's the power on top of the G? What's the power on top of the H? So what do you conclude? Without even doing what we did, like we did with the EK. What did we conclude? With the EK equals half mv squared. Changing the speed gave you more, as we say, bang for your buck than changing what? Because the speed had what power? And mass had what power? Here, all of them have the same what? What does that mean? If you double your mass, do you still get the same effect if you double your G? Do you still get the same thing if you double your H? But which one is near impossible to change? Gravity acceleration, because that requires you to go to the moon, to Mars, to so. Okay. All right. What was the original mass? 5 kilos. What did I do here to the mass? Can someone now compare what's 294 divided by 147? It's exactly what? How about tripling? Can you divide that by that? What do you get? 3. So what does that mean? Is the same effect to both times? I told you, it's the linear. What does linear mean? Whatever you do to one, you get the exact same effect to the other. Okay? How do you think those numbers are going to be if I change? By the way, which one did we change here? Mass or elevation? Mass. Now I'm going to change what? Did I get the exact same final results? What does that mean? Which one affects the change more? Changing the mass or changing the elevation? Or neither? Which means what? You decide according to the what? To whatever materials you have now. It has nothing to do with physics. It has to do with supply and materials and engineering and convenience. Whenever you do what? Gravitational energy, you have got to decide on a what? On a what? On a reference height. What do I mean by reference height? You can take your reference height to be anything that you claim to be what? Convenient. You can take what to be your reference height? The ground. You can even take the what? You can take the ceiling. You can even take what? The table what? Surface. But everyone, you have to make sure, listen up, 2 things. Whatever you choose as your reference height, you stick with it for the whole what? You do not change it halfway through. You do not say, okay, I'm going to do a few steps using the ceiling as my reference height, and halfway through, I'm going to make my what? Sorry, that is going to completely destroy the problem. What's the second thing that you need to understand? Everyone, listen up. Anything above your reference height, like math, is going to be given what value? Positive. No, above. Anything below your reference height is going to be given what? A negative elevation. How about anything at your reference height? How about anything neither above nor below? Right at, that's what? That is at your reference height, which we claim to be what? The zero level of the problem.